Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Resonance energy, delocalization energy, is the difference between the theoretical heat of hydrogenation, assuming no aromatic stabilization, and the actual experimental heat of hydrogenation. Moving on to the next step. Determine the number of double bonds in anthracene. Anthracene is a tricyclic aromatic compound with the molecular formula C14H10. It contains 7 formal double bonds, or equivalently, it can be drawn with 5C is equal to C double bonds in a kekulé structure, but for the purpose of hydrogenation to perhydroanathracene, the total H2 consumed corresponds to reducing all pi bonds. Anthracene has 5 double bonds in its kekulé structure. It requires 5 equivalents of H2 to fully hydrogenate to perhydroanathracene, giving C14H24 from C14H10, a gain of 14 H atoms is equal to 7 H2. Wait, let me recount. C14H10 plus XH2, C14H24, so X is equal to 24 to 10, 2 is equal to 7. Anthracene requires 7 H2 molecules. Moving on to the next step. Calculate the theoretical, non-aromatic, heat of hydrogenation. If anthracene had 7 isolated double bonds, like cyclohexene, the expected heat of hydrogenation would be 7x minus 28.6 kilocalories per mole is equal to minus 200.2 kilocalories per mole. And for the final step, the actual heat of hydrogenation is minus 116.2 kilocalories per mole. Calculate resonance energy. Resonance energy is equal to vertical bar theoretical delta H vertical bar actual delta H vertical bar is equal to 200.2 to 116.2 is equal to 84.0 kilocalories per mole. Why other options fail? B. 100 kilocalories per mole would correspond to a different number of double bonds or different reference value. C. 110 kilocalories per mole and D. 116 kilocalories per mole do not match the calculation. The resonance energy of anthracene is equal to 200.2 to 116.2 is equal to 84 kilocalories per mole. Therefore, the correct answer is A. Therefore, the correct answer is option A.